Alright, we're looking at how to do shear and moment diagrams using our singularity functions in Excel. And so looking at it, looking at the shear, we're going to start out with R1 going up, and then at x is equal to 4, we're going to turn on 200 going down, and then at x is equal to 10, we're going to turn on 100 going down, and then finally when x is equal to 20, we're going to go 20, R2 going up. So that's our shear. And then our moment, the moment as we're moving from left to right, we're going to start out with R1 times x going up, causing our beam to bend upwards. And then once we pass here, we're going to have a 200, and then the moment arm will be the x minus 4. So it's x minus 4 to the first. So we're just integrating 0 to the 1. And then minus 100, x minus 10 to the 1, plus x squared, x minus 20 to the 1. So that's going to counter this out right there. This one is negligible because we're going to go all the way down. We're never going to go past 20. So this one doesn't really need to be included in our problem. So taking this, copying it, and then pasting it into Excel so we can see it as we're doing. And so now basically we have two unknowns of R1 and R2. And so we can calculate those. And so basically if we take the sum of the moments around here, it should be 0, so it's 200 times 4 plus 100 times 10 minus R2 times 20. And so R2 is equal to 200 times 4 plus 100 times 10, and then divided by 20 is 90. And then we can just use the sum of the forces in the y, so get R1 is equal to 200 plus 100 minus R2. So plus 200 plus 100 minus R2. And these are in pounds. And then we want to basically plot our shear moment diagrams in the x direction. And so this is our x. 0, 1, drag this down to 20. So there is our x. And then our shear. To turn something on, you can use a greater than 0. And then to make it look pretty, this R1 only starts at 0. And so it's equal to, well, let's make things pretty by adding names. So in our formulas, we can create from selection. So now this cell is R1, and this cell is R2. And in this column, we can label x. So now our formulas look like this, so it's equal to R1 times, and this is going to start if x is greater than 0, minus 200 times, and this is x is greater than 4. So this will turn on when x is greater than 4, minus 100 times, and this is x is greater than 10, and then plus R2 times x is greater than 20. And this is just to make that last sharp edge at the end. And then we can paste our formula down since we use names. And so now we can insert so we don't want a wavy line plot, a straight line plot. And this doesn't go up because they're next, so if we change this to 0.001, and then starting at, where is our next transition? Our transition is at 4. And so if we insert a line here and do 4.01, now we have a straight line there. We could go back here and insert our 1. And then our next transition is at 10. So if we insert 10.01, then we have a nice straight line, and then we need to go down to 20.01 to get our transition at the end, and then drag it down. So now we have our shear moment diagrams, and it starts and ends at 0, which makes us happy that we did these calculations correct. So there is our shear plot. Now we can do our moment plot. And so moment is equal to R1 times x is greater than 0, minus 200 times, this one is x minus 4, so it's x minus 4, and we need to turn it on at x is greater than 4, and then minus 100 times x minus 10 times x is greater than 10. So to do the singularity function, it's the function in the brackets, and then to emulate the brackets, it's x greater than 10, or you could use greater than or equal to. And this is to the, so since it's to the first, it's the first power, and then the turning on, and then we have to add plus R2 times, and then we actually don't need x minus 20 times x is greater than 20. And this last part is not going to change our equation at all. Do our plot, and then we can come to here and drag our plot over, and now our shear moment diagram ends at 0. And since the moment starts at 0 and ends at 0, then you don't need this extra term in there to make it look pretty. So our moment starts in 0 and ends at 0, our shear starts at 0, ends at 0, so we are confident that we have our numbers correct. You can add axis labels and things like that to make it look pretty.